After our conversation about the number sets, we begin talking about closure property. We begin our conversation about closure property not by talking about it as a property, but just by exploring with numbers and operations. The first number set that we explore is the set of natural numbers. And after talking about what the natural numbers are, the expectation is that the students can envision the entire set of natural numbers when we begin this conversation. The first thing I'll have them do is pick two natural numbers. Most students will say something like 1 and 5. And when we add these two things together, we get 6. Now, the value is not what we're concerned with when we begin our conversation about closure property. And so, really what I'm asking them is, when I add 1 and 5, will I get another natural number? So, we continue to do example after example, just getting them to do some very simple addition. So we'll add 7 plus 5, and we'll get 12. We'll add 12 plus 3, and we'll get 15. And we'll see that 12 is natural, 15 is natural, 3 is natural, 7 is natural, and all these numbers that we add together give us a natural result. So we'll say, because the result seems to always be natural when we add two natural numbers, mathematicians would say that the set of natural numbers is closed under the operation of addition. So here we have a reason, and it just says because when you add two natural numbers, the result will always be natural. The question that I ask the students is this true for other operations? And so we'll look at other operations and we'll explore each of the operations here, addition, subtraction, multiplication, division, and exponents, to see what happens when we perform the operation on the set of natural numbers. So here, as we talked about with addition, we could write n for natural, and if we refer back over here to the symbol, we see that the natural numbers can be expressed as this n, just as an abbreviation. So we have n plus n equals n. And the students see that and they read it, but I want them to understand that n is a natural number, and so we say for addition, the sum, one of the key words from our conversation about the order of operations, the sum of two natural numbers is always natural. And it's important for it to always be natural. So here we have more examples. Now, if we look at the difference, or subtraction, we see that the difference of natural numbers is not always natural. So here we have 5 minus 2, we get 3, but 2 minus 5 is negative 3, and negative 3 is not natural. So students will say there are several examples where we get natural numbers when we subtract two natural numbers, but because it's not always true, we'll say that the set of natural numbers is not closed. Okay? And actually, a natural number minus a natural number is an integer based on our conversations about the number sets before. Multiplication is next, and we see that n times n equals n, which means the product of two natural numbers is always natural. Okay? Now, what we can say is that natural numbers are closed under multiplication because the product of natural numbers is natural. And this is just everything that's stated here written out in words. We go through examples of each of these. So for the sets that are closed, the students have a strong sense of, okay, if I multiply two natural numbers, I'll get a natural number. But for here, these sets that are not closed, subtraction and division, we tried to highlight some examples. So here we have n divided by n is q. Q from our conversation about the number sets is a rational number, and so here we see when we divide two natural numbers, we get a rational number. It says the quotient, that's the result of division, and actually what the Q stands for, of natural numbers is not always natural. Okay? So natural numbers are not closed under division because the quotient of natural numbers is not always natural. It's written out in words. So as an example, we see 10 divided by 2 is 5. 10 is natural, 2 is natural, 5 is natural. However, 2 divided by 10 is a fraction, 1 over 5, or 2 over 10, which is not natural. It's not whole. The last operation that we discussed is exponents, and here we see n raised to the n power is equal to n. A natural number raised to a natural power is always natural. And so we say natural numbers are closed under exponents.